Hi everyone, welcome back to another Calculus 12 video. Today we're doing 7.2 derivatives of sine and cosine functions. I've already drawn out some of these graphs, but I'll start out just with these two boxes. I don't know what to say to you, you just have to memorize these. If we're taking the derivative of sine x, know that the answer is cos x. And if we're taking the derivative of cosine x, the answer is negative sine x. So the derivatives of sine and cosine are cyclical. I'll show you what I mean by that. So if we start with a basic sine x graph and I take the derivative of it, it looks like this, which is a normal regular cosine graph. So that's the original. And if I take the derivative, we get this. And if I then take the derivative of that, I get negative sine x. And then if I take the derivative of negative sine x, I get negative cos x. And if I then take the derivative of that, I get sine x. So if we take a look at, I'm going to shrink this down and zoom out so you can hopefully see all of it. But if you look at it, the whole cycle from here to here through 1, 2, 3, 4 rotations of taking the derivative. So after the fourth derivative, the function reverts back to its original. So if you notice, sine x here is sine x here once we go through the rotation of taking the derivative 4 times. So that's helpful and useful to know for when we come across something like this. It says given f of x equals sine x, calculate the 47th derivative of f, and this is how we would write it, f 47 of x. But that looks crazy, like how would I take the 47th derivative of something? This is where the pattern of the 4 cyclical graphs is helpful or useful because we can use that to make things a little bit easier or quicker to work with. So math is all about working with patterns, as you hear me saying often. So I would take this and I would say, okay, so I know that 47 is my end goal, but I also know that that's like I'm looking for multiples of 4 because I know about that cyclical pattern of the 4th time taking the derivative, I go back to the original. So I'm going to say that's the same thing as 44 plus 3. I just want to fit in, multiple of 4 that's going to work evenly in this 47. And then 3 is what I have left over. So that's my method of thinking, mode of thinking. I hope that that makes sense to you. So that's what's going on there. And so if I think about it, I just need to think about what the third pattern was going to be, and that's what my answer is going to be. So the third pattern, meaning this one here, which was negative sine x. So f 47 of, what were we starting with? Sine x of sine x is equal to negative cos x. Let me go back to this again. Sorry, I think I put a star on the wrong one. It's this negative cos x because we're doing first derivative, second, third derivative. And that's how we got this. So this would be our solution after all of that. Okay, so there's the first example of how this may appear. And we'll move on to another one. If we want the derivative of y equals sine of 3x. So we learned about sine x, but this has 3x. So to me, that's an indication that I'm going to use the chain rule. So I really do say this every single class, but I mean it every single time. It is not, like this is not necessarily new content. This is us following the same patterns of working with derivatives, like the chain rule, product rule, all of that stuff, power rule, but now it's with trig. So if you use that mentality and approach, it'll make things easier for you to make the connections instead of viewing it as a bunch of separate stuff. I think that's what makes it easier for you if you can see it as being connected. So if we want to take the derivative of this, we are going to say d dx. I'm just using this notation today, you don't have to. d dx of sine x times d dx, so taking the derivative, of just the 3x that was in there. So this is us applying the chain rule. So take the derivative of the whole thing, multiply it by the little part that was inside. That's what we're doing. So what we get after that is cosine of 3x times the derivative of this is just 3. So I should have maybe said dy dx would be the whole thing, right? So dy dx, which is the thing that we're looking for. So overall, I'm going to move this up. Dy dx, the best way for me to write this is just to slide the 3 out front, would be 3 cos 3x. So there's our answer. So that's that for the first one. To tell you the truth, we could stop the video there and be done with this because you know the rest. Like, again, it's not really even anything new. We are taking the derivative of this, so we do want dy dx equals. Notice that there's way more stuff going on inside, but it's still the same thing that we're doing. We're still going to use the chain rule. So we will still do d dx of this would be negative sine, and then all of this stuff, x squared minus 2x plus 3, right? So I take the derivative of the whole thing, so that's good, it's that part. And then I need to multiply that by the derivative just of this part. So times, I'm just going to put it here nicely and neatly in brackets, and it's going to be 2x, we can just use the power rule in this case, minus 2. And the constant at the end is just 0 when we take the derivative of it. And so when we put this together, it's probably easiest for us to clean this up by moving this out front and distributing that negative. So this becomes negative 2x plus 2, right, when I distribute that negative to both of these terms here and here. And then sine and everything inside, x squared minus 2x plus 3, like this. So dy dx, after working on all of this, ends up being this whole thing. Okay, again, as usual, if you are getting the hang of it, you could hit pause, try this on your own, and hit play when you're ready for it. And if you don't want to, you can just follow along. Same idea, we did the chain rule a couple of times. This time we have the product rule. So remember, I'm feeling okay today, so I think I can color code this and keep the color straight, which is the hardest part when I'm teaching. But I know that you know the product rule, but let's just do a quick little rundown of what that would look like. So reminder that it's f prime times g plus f times g prime. If I'm going to call that f and call that g. So we know that that's what we're working with, that's what we're interested in. So we just simply go through and define what each of those are. So when I look at this sine x, well, when I apply it or put it into here, the derivative of sine x we know is cos x. So that deals with that part. And then I just want to make sure that I was going to get lazy with the colors, but I'll do it separately. So that takes care of that. And then I need g, which was just another cos x. So that would be cos x from here. And then it would be plus f, so just the original sine x, times g prime, and we know that g prime is negative sine x. So again, you get what I'm saying. This is not new stuff. This is just the trig part. Trig derivatives is new, but all the other stuff, luckily, that we do is just a repetition of the same old stuff. So here we would get cos squared x when we multiply these two. And then here we would get minus sine squared x when we put them together and simplify, when we multiply those two out together. And so here's some review. I don't know if you remember these, the Pythagorean identities, but remember cos squared x minus sine squared x is also the same thing as cos 2x. This would be the best way to give our dy dx, or our derivative of the whole thing. So I hope you found that useful. That is it for this section, and there's your work.